All right, welcome on in. Good to see you. Hey, Kunal, good to see you. Welcome on in. Happy Sunday. We're going to be continuing our Rust Retrieval Augmented Generation. And I had to reboot my computer yesterday, so all the things are in different spots now. I think this is the right directory. By cargo, is everything in there? Is this right? Yep. Anyhow, Axum, SQLite, Turbovec, and our Tokyo. All right, we've got everything we need. RAG, yep, we did. There we go. We got some RAG going. Retrieval Augmented Generation. You got it. Absolutely. Looking forward to this. All right, so we need to get our web server up and ready so that way we can start accepting documents. We need to be able to accept documents, and we also need to be able to accept user prompts to query the RAG engine, right? The RAG engine is going to give us all the data back. So we could do a couple of approaches, right? One, we could prompt and get back all the raw context. That could be one of the responses. Another prompt could be just to have the AI answer based on the data that it finds. And I think that's something that we also need. So that's another to-do item that's missing here in our code. We can figure this out here. All right. So where did we leave off? All right. So pane, resize pane. Let's go down 10. All right. That's good. Maybe do up 1. Let's do resize up 1. I think maybe up 1 might be helpful here. There we go. Happy Sunday. I enjoyed my Sunday. You did? You had a good Sunday, Kunal? Nice. Good to hear it. Did you, what'd you do? What'd you do? I don't want to say, I'm not going to say. My Sunday was not like yours. Mine was definitely different. I had some issues. Things happened. And let's see here. And I hope things are going to work out, but I think they will work out. They will. Just not today. Just not today for me, but that's fine. All right, so we need to see if we can return. All right, so today's plan to do your Sunday ended, your started. Yep, that's right. Here we go, getting started. 8 a.m., 8:19 a.m. here. And it's a little bit later over there. About 8:50. Yeah, 8:49. Where you're at, probably. I'm guessing. 8:49. Yep, there we go. 8:49. Right there. All right. 1 second here. I'm going to pause this and then play again. Here we go. Okay, good. Okay. So our to-do is for today. It would be great if we could get our web server. You smart? Well, it's like just a little bit smart. How's it going there? YXNGRRX. Good to see you. Welcome back. 3377. How was your 20s? They were an adventure in Silicon Valley. I created companies. I created startups in Silicon Valley. It was a lot of fun. And I'm still at one right now, although I moved to Seattle. So I had a good 20s, I would say. Yeah, started this company PubNub for communication. It's called PubNub. We did some communication there. Communication APIs that allow your phones to talk to each other or devices. And we have a lot of devices on our network already. Over 1 billion devices. So pretty good. I'm really excited to eventually tell you the full story at some point. Because there was a lot of adventure to be had. All right, so this is our one to do here. We want this right here. So this is today's main goal. I would love to be able to capture the body and the prompt and then pull it into memory. That's what I'd love. I would love to see that. And so this would be a JSON post. So let's see, I want bacon. A little bit of bacon in there. Boom, bacon. Ooh, so good. That's good bacon right there. Hey, Soki, good to see you. Welcome on in. Happy Sunday. You're learning natural language processing. Natural language processing. Right now for your exam, it's kind of dry. I like NLP. I love it. I'm not motivated. I managed to cover half of the content so far. Oh, it's so interesting. There's so many things you can do with that technology, and you can improve it really fast. And it's part of the large language model. It's baked in through the embedding layer. It's so worth it. It's really good. Oh, Kunas. Hey, we're back. Yep, good to have you here. Have you worked with TF-IDF vectors? Not directly, indirectly, and without really realizing what I was doing. Yes, many whiles ago. All right, so that build looking good there. I would love to be able to run this. Cargo run. And it's going to build, run, and it's going to bloop. It's going to be done. Oh, yeah. Just prints out hello world. Okay, so what we need to do is we need to get our main to pull in. Where's our rag at here? All right. So that's a Turbovec. We're going to be doing this as well a little bit later. We need our router Tokyo listener here. All right. So we need the listener. We need this part right here. By the way, you're making an AI B2B or for public use. Right now, this is public use, and it's going to be production grade mega scale for the RAG. For the past streams that we did a transformer in Rust, our GPT, and we built it. It works. It's public. It's available. It speaks Steven. If you want it to speak Steven, it'll speak Steven to you, which is me, right? It's gonna use my words to talk to you. Like, if you want. Doesn't do anything else though. That's all it does. All right, let's get our listener here. All right, so Tokyo Net TCP listener. All right, let's do this. Here we go. All right, server started. Good to go. All right, let listener equals. Was it Axum? Yeah, Axum. Wait, right? Oh, Tokyo. Oh, we need to do Tokyo. Right, okay, Tokyo. Net TCP listener. Net TCP listener. Are you doing hybrid search or hybrid? Soki, we're doing hybrid. We are doing hybrid. The plan is printed out here. We're going to be doing database with BM25, BM25 FTS plus vector search for ranking. There we go, right there. That's our answer. Boom. That's what we're going to do. How's it going? Glad to see you. AW, good to see you too. Welcome on in. Happy Sunday. Will you charge people to use it? Oh, no, it's free. It's free, but you have to run it on your own hardware. You got to run it on your own hardware. Our TCP listener. We are going to get our next song. Here. Here we go. Next song. Okay. Where is our... Here it is. Okay. Bind on the host port. I'm going to create a host port here. Let's see here. No. Let host equal 0000 colon. We'll do 3000. And we'll say host. Await unwrap. Okay. Await dot unwrap. Okay. And then let's see. Oh no, Axum serve. Right. Okay. Axum serve. What's going on over there? I mean, you can do different types of searches, right? Yes, you can. Different types of searches. Cosine similarity within embedding, semantic search. Yep. And doing a keyword search. Exactly, Soki. Yep, that's what we're doing. You got it. Yes, indeed. Yep, this is basically, right. So we're going to do keywords, FTS/FTS, BM25, right. And vector all in one. So like multiple right there. Serve. Let's go back over here. It's going to be Tokyo serve listener and app. Let's see, listener and app dot await unwrap. A little bit of unwrapping there. I don't know about that. Hey, Bonzupi, good to see you. Happy Sunday. Hope you're having a good Sunday today. That's the best option, IMO. Yeah, it's good. I think it's going to be a good one. We're going to use it. Using GPT API and building your own stuff. Oh, well, my AI won't let you do that. However, it's possible that you can do that. Oh, wait. What? That's crazy? Wait, like, oh, wait. Yeah. No, it's just me. You won't be able to build. You won't be able to build with it. We could program it to do that, though. It would take a lot longer. Unwrap. I know, Bonzupi. I know. Hey, it's only right here, and it's fine if it panics because it means it can't start. So it's actually okay, right? It's not okay. It's not. I know it's not. Never mind. It's not okay. All right, Bonzupi, what should we do here? Should we unwrap? Should we do a match on this? What should we do? What do you recommend? Hey, how's it going there, Erdem? Good to see you. Happy Sunday. Welcome on in. Good to have you here. Glad you like the setup and keyboard. Yeah, got to start coding your... Hey, there you go. Loads of things to do. Yeah, lots of things to do, you guys. A lot of to do. All right. Hey, how's it going there, Rock? Good to see you, Rock and Brian. Rock and Brain. Rock and Brain. Good morning. Quick question. Rust will pay my bills in the future. I think so. I think so. I mean, it is for me. It is for me. It's working really good. You just set up Hermes agent. Nice. Oh, Bonzupi. What should we do? Should we do a match here? You think that'd be better? A little bit of matching there? What do you think? Close this out here. All right, so I know we don't do these unwraps and they're bad, so I suppose we could do something else, right? Make match. Not do an unwrap. Fine, right? Here we go. And then we'll say, okay, listener. And then we'll return the listener, right? Is there a better one? Is there a better, what do you call these, combinators? Is there a better combinator where I can just grab it or unwrap or? Well, I don't know what I'm unwrapping though. I don't know what the default would be. We could do unwrap or else. Okay. Which lets you handle the error case. All right, let's do unwrap or else, right? So can we do like an if let? If let, right? And then there could be like an else or something. How's it going there, Ruchit? Good to see ya. Happy Sunday. Good to have you here. All right, if this is open source, like I can use it to build your own projects as well. Well, yeah, you could. It is. It's completely open source. We put it on Discord under the link share. So if you want, you know we're doing it right because we have given, yeah, Rust transformer. Here it is. So this is the code that we wrote, and we made it really easy. Only 3 files. Really simple, right? Main file. It's going to load, and it's going to run some prompts, right? So we gave it a few prompts here. So we got a few prompts here, and then we also training it. So it's model.ot is the model, right? So that will give you the model, and then the tokenizer, free right here. We wrote it ourselves, custom tokenizer, and then our transformer, which is right. We wrote that all live on stream, so you know we did it for real. It's not pretend. It's right there. Oh, unwrap or default is also a thing. Would that work in this scenario? Because if we can't bind, then we're out of luck, right? So if we try to double bind, the OS is going to say, nah, you can't, nah. You already have something listed on port 3000, so you can't double bind. Let's see. I like your whole GPT Git repo as just building something. Yeah, exactly. Thank you. We're building it, you guys. We're building it. All right, we need to figure out what we want to do here on this line right here. Oh, Mr. Blum, yes. Do you recommend learning C++ or Rust currently? Well, they're both good. I recommend Rust if you're going to pick between the two. PyTorch, you want a PyTorch. So then if you want to be a PyTorch expert too, hey, there you go. Then Python is your answer. Or Rust. You can do it in C++ as well. You can use libtorch in all 3 languages, right? Libtorch in every language. Unwrap is probably fine in this case. All right. We'll just do unwrap for now. I like doing match though too. Unwrap. All right, there we go. No errors? Nope, we still got an error. Where's our error at? What does it want? Expected tuple? Am I missing something? What are we missing? All right, let's find out. Unwrap. Oh, serve listener app, right? Do I have that? I have that right here, right? Where's that at? Right here. Oh, does it need to be a tuple? No, it's not. It's just Axum serve listener here. What if we did this? Okay. Not. Okay. So we've got a problem here. All right. Listener TokyoNet TCP listener. Let me see. Oh, bind. Okay. I was missing something. There we go. X. There we go. Perfect. Okay. Oh wait. Cannot find function server. Serve. It's not serve. Okay. Yeah. SRVE. Axum serve. Survey. Right there. Cannot find app. Oh, did I call it something different? Yeah, I did. Okay. There it goes. All right. Nice. All right. Let's see if we got our server going here. Run. Server started, right? Wait. Oh, it's not. Oh, wait. It actually probably did start, right? So what we need to do is say starting server. Let's do this. Say starting server. http://host. There we go. Try it. Let's build, run, rerun. All right, there, right there. We did it. All right. We got our server going. It only took a little bit. Ooh, Primogen. Michael says Python is either trash or one of the best languages. Well, it's both, right? Because it's not the fastest or most performant language. However, it is really expressive. It's a lot of fun to write in Python code because you can do list comprehension and dictionary comprehension. Weird things, I know, but they're pretty expressive and really powerful, and just like the minimal syntax is stunning. Plus, you can use all these fun symbols and operators and overload them for every single class, which makes something like PyTorch possible. So you can do matmult really easily, like a beautiful matmult, right? Import torch, right? You could say torch.tensor. And then I could, how are we just gonna do this? Yeah, tensor A, right? So A equals, I just love this so much right here. Okay, where are we? 1 second, let me go back over here. Let me see here. No, we don't want to see that. All right, Python, we'll redo that. I want very much to do import torch again. I'm gonna show you this because I love this. This is my favorite part. Look how simple and clean it is. Right, A equals torch.tensor, and then you create an empty tensor 1, 2, 3, and then I think we will make it a 2-dimensional tensor, and then we could say B, and then you say A at B, like that. Oh wait, that should have done it. Oh, the shapes don't match. Okay, we could fix that. Real quick. What if we made them A and B? Both like this. So now they are, oh, well, we transpose them. We should transpose them. So B dot T, right? A and B, and then you say A at B. There. This is the syntax that I love. I love that syntax right there. PyTorch, way better than TensorFlow. Yeah, I like it. It's very popular. It's very popular. Your first Linux was Kali Linux. Woo, Kuno, really? You went straight to the heavy duty Linux. All right. You're also wondering how come with functions programming, like right now, small data sets, C++ and Apache Arrow is too much given your skills. Oh, you cannot think of any solution at the moment. Wait, what do you mean? What do you mean? You've got a good solution. That seems perfectly fine. For small data sets, use SQLite. Really fast, extremely performant. Has relational beta. You can use it to do aggregations. SQLite, you guys. Really good. Your first Linux was, wait, what is that? What kind of Linux is that? Diabolic. I don't know. I've never heard of that. Never heard of it. All right, let's see if we can test our server here, you guys. So we've got our server. We can do curl dash data. So can we do that? Dash D. Let me say http://3000/3000. We do that. Boom. It worked. Now what would be nice. Hey, how's it going there, John Doe? Thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We're currently building a Retrieval Augmented Generation because you guys asked for it. You're like, hey, we need it. We need you to build it. Hey, that Basper, good to see you. Been a lot. Good to have you back. Oh, Soki, you like PyTorch too? Clean syntax. Yes, I love it. I love that clean syntax. So very satisfying. The data loader. Yeah, which makes you able to use their data loader. Yeah, they've got a data loader. They do have a data loader. They do. And I often have to always look up the docs every time I use a data loader. Second was Arch Linux. Nice. In TensorFlow, you need to implement your own iterator. I mean, it's okay, but yeah, PyTorch is way better. Nice. Okay. It's old, mostly defunct 5 Linux. All right. Where did you learn, by the way, where did you learn about large language model? I tried it, through the paper, right here. I learned through the paper. It took a long time. And then I, read other articles and people, breaking it down and like, what's QKV? I don't even know what is QKV. I have QKV right here. What are those variables? Well, it turns out, you know what? They're the same data. It's input data. It's just copied 3 times and put through a projection, which is a matrix. That's all it is. What does RAG do? Retrieval Augmented Generation is a way to do like a Google search on your data. It pulls back the most relevant data, documents, and puts it into chunking. It slices the data so it gets the exact context that's needed to do prompting on a large language model like ChatGPT. Right? So that's what we're doing. We're building that right now. Attention's all you need from... Yeah, there we go. 3 brown, 1 blue. I forget what... brown and blue, yeah. 3 brown, 1 blue. Transformers make a lot of sense. 3 blue, 1 brown. Yes, thank you. Thank you, Banzupi. That's right. Yeah, nice. Okay, so what do we want to go from here? All right, so I want to say println. Let's see. We've got our request. Data, or requester. Posted data. All right, so let's see if we save that. Start and reload. Run it. Yep, there we go. You can see right there. We're posting data. Okay, what would be nice is to be able to grab that data now, right? So we can grab that data. So prompt body, all right, prompt JSON is gonna be a prompt. In order to get this to be a JSON structure of sorts, we wanna say text. All right, so I guess we could say text, and we're gonna say hello, like that, right? Looks good to me. All right, double check. Is that correct? Yeah, I think that looks good. Okay, good. He's got an excellent course on calculus, which is pretty useful for understanding vectors. Oh, nice. Yeah, understanding vectors is a really big, important part of this. All right, so let me, and AI and stuff. All right, so see, JSON. How do we do this? Survey JSON, yep. Response JSON. It's going to give us back JSON. It's going to respond with JSON, which I do like. I like that idea. Oh, and value, right. So do we have Survey JSON? So we can parse it. Okay, so I need to grab Survey, which I don't know if we have. So cargo add Survey JSON, right? Like that. All right, good to go. Okay. Let's interest up here so we can grab our use Survey JSON, and we want our value and JSON macro. That's what we want, value and JSON macro, which we will love to see that. Here we go. Okay, now we need to figure out this part right here. If I close that out, reload here. And then I should be able to curl. All right, we're curling. Looks good. Excellent. Okay. Now we just need to figure out how to deal with this. JSON. Can we do JSON value? What if we did that? What if we did just JSON value? Because we've got the value right here. Right? Right here, right? So it should work. So it's just a regular value. What is it looking for, though? Oh, colon. There we go. Hey, thank you for the hearts, you guys. Appreciate it. Good to have you here. Happy Sunday. Happy Sunday. Henry. Hey, good to see you, Henry. Welcome on in. Your friend dropped on you a McRib, but not currently available on the menu. Ooh, you got a McRib and it's not even out there yet. Nice. Very nice. Have you heard about softmax when I made my neural network from scratch? Oh, you have heard about softmax. Oh, wait. Okay, you're talking to the... Softmax is a great function. I just think it's often overused in some situations that you don't actually need it in. All right, so do we have our post data? I would love to be able to print this out now. I would love to say what our body... So is it body? Is that how we want to do this? Let me look. All right, so this will... Async function JSON is going to return just regular... Okay, so it's just a pass-through. Okay, that looks good to me. We should also return data. So JSON, and we're going to return the macro value of a dictionary. And does it? Yeah, okay. So here we go. Just empty. It's going to be empty. Like this. That should have been fine. Oh, here we go. All right. Type mismatch. Oh, right, because we need to return. We're going to return a JSON value, right? Something like that. Is that gonna work? All right, there we go. Now we should be able to see something here. Expected request with content type. Now, I would like it if I didn't have to do that. I don't want to have to do that. I want to exclude this. Okay, so let's figure out how to solve this here really quick. Oh, hey, Ruchi. Okay, pal, hey, completed full max version. You can check my agent.py. Oh, you did, nice. Hey, that's awesome. You're a fixer, right? You made it fix. Wait, functional programming. Let's see. Build your own LLM from scratch. Good book. Ooh, you found his PDF online. There you go. The free version. Ruchi, that's great to hear. Congratulations. That's fantastic. Okay. So I want to fix this right here. Let's fix this really quick. Okay, copy. And we're going to go to Google really quick. All right. Axum, remove, header, content type requirement. I want to remove that. I don't want it. Do not want it. All right. I do want to add this. So I want to add that macro really quick. I know I want that for our this. We should also add it for this too. All right. So this will be a derive, deserialize, and debug. We don't need to deserialize this though. We want to derive, debug, right? Like that. Just regular debug. Yeah. In brackets. Okay. There we go. And then for this, we want to derive, debug, and deserialize. Can we do that? Do we need some Serde deserialize? Okay, we can do that. Serde JSON. Here we go. Deserialize. Good to go now. Good to go. Serde underscore JSON. We don't have our deserialize. All right. Well, that's fine for now. Don't need to bother with it. We'll deal with that later. All right. You have my GitHub link. Big thank you, pal. Yeah, got the GitHub link. Absolutely. If you feel free to share it again on Discord. Send it again on Discord and then on the link share so like it comes back up and then we could go take a quick little look at it. Don't really know enough about functional programming. Is it worth it? Take a look. I love functional programming, Soki. It's really good. It's clean. It's satisfying. You can do it in Rust. You can do it in Python. You can do it in JavaScript. It's available everywhere. Sending now. Nice. All right. Good to hear. So I would like to be able to return. The only thing is it's expecting content type application, which I don't want to deal with that. I do not want to deal with that. Oh, I forgot about status code. That's right. It's been a while since I've done this. All right, so I want the solution manually parsing with bytes. No, I don't want to do that. Instead of using your directly bytes. I don't. No, I want a different solution. No. Different. I want another solution because I don't like that one. Let's see. Give Haskell a try. Yeah, that's what we're gonna do, Bonzupi. We will. We're gonna do Haskell. We will doing Haskell. We'll like it. Oh, no, I don't like that either. No, I want something simpler. I want it simpler, not a loose JSON. Are you kidding me? No. No. Is there a third option? Middleware layer. Yes. Yes. That's what I'm looking for. Header. Here we go. Axum middleware. Insert. Request. Headers insert. Yes, because it's always going to be application JSON. This is what I want right here. Force JSON content type. I like this better. Okay. Next run. Wait, okay. All right, yes, I want to do this. And then we paste it in as a middle layer here. Perfect, okay. It's not the greatest, but it's definitely better. It's definitely better. Okay. All right, let me see here. Set, paste. Send you a DM check, please. Okay. Let me paste this in really quick. Set, paste. There we go. And then I'm going to paste this in. Axum body. All right, so I need this. We needed to do this here. To do. There we go. And then what are we missing? What are we missing? Oh, hey, not Betty White. Good to see you. Welcome on in. Happy Sunday. Good to have you here. We're building ourselves a Rust Retrieval Augmented Generation system right now. And we need to do this right here. Copy paste this. Okay. All right. So this is code for after. Set no paste. You joined the right channel for software engineering. We are currently building with Rust because it is a very challenging language and a lot of fun at the same time. All right, so you said to check over here. All right, cool. Auto heal. Let me go back over this real quick. All right, bring this back over here. All right, so you said agent.py. All right, let's take a look. I love this. I love that part. I always love that. That's great. I like to see that right there. All right. Let me do this here. I'm going to copy it so I can read it in my terminal, so that way I can more easily deal with it. All right. So pb paste agent.py. There we go. Okay. Look at that. Oh, it's so good right there. Auto heal. Oh, it's so good. Very satisfying. Okay. Nice layout with your help. Print welcome. Looks good. All right. You got an encoder there. Base 64 encoder. Nice, clean, simple, easy. Hey, Bazinga! Welcome on in. Thank you for clicking the hi button. Good to have you here. Haskell. Yeah, I like some Haskell. All right, so you guys. So this is a little bit too much indentation immediately. So I remember we were talking about this. It does appear better. Let me see here. It's a little bit better. There's just a lot of if statements. There's a lot of if statements here. And what you could do is do a match statement here. So instead of doing this, I'd recommend doing a match statement. Do a match. In Python, I recommend a match as a better approach instead of a giant if-else. And then instead of doing all the logic here, it might, well, it's actually fine. Maybe just a regular match statement would be better. Match case. Yeah, there you go. Exactly. Match case. Yeah. So wait, I very rarely do this in Python. So Google match statement Python. And also let's change the song up here really quick. Let's get the next song going. Is that good? I think that's good. Okay. Quick little example here. Yeah. So match command case, case, case. So this is a really good scenario when you're just comparing the same variable over and over and over, right? Which you're doing here in your command, which is your command right here, right? So you just reusing the command over and over, and you could just do a match case there. So that's a way better approach on that. This is fine. Looks good. I like this. Yeah, got the headless browser going right there. Very nice. Screenshot. Ooh, that's cool. I like that. That's nice. This is cool. All right. So this part right here that you have is probably the most impressive and rare in seeing in software. So I think you did a good job there. How did you miss so many lines of code? Oh, don't worry. We didn't write this. You didn't miss much. Here, this is how many lines. We barely have like 100. We barely have 100. And we copied and pasted a giant chunk here. So you didn't miss anything, Sergio. You didn't miss anything. In Python, match case, but in Java and JavaScript is switch case. Exactly. Exactly, switch case. Okay. Universal LLM with back off. Okay, this is neat. Still a lot of indentation here, right? And then I would stub out each of these into separate functions for each of the providers, right? Because you've got multiple providers here. So just some code tidiness, just to clean it up. But I do say it is very clean. It's a literal agent. It's a good agent, and you did a very good job. Very good job. Nice. You did good. You did good. Okay. XHTML request. Well, do we still use? You use fetch now, right? Fetch instead. Fetch, which is the new one. Okay. Close out of there. Done. Excellent. Okay. So let me get back to our code here. I really want to get our server running. All right, so I actually should be able to get a response now, although I need to fix this problem here. So let's fix that problem. We're gonna do that with, where's our Axum at? All right, here's our Axum. Looks good to me. We're just gonna make sure we've grabbed these guys here. So we want our body. Do we use the body? We do, okay. We use our header. So we do, yep. And our request. Looks good to me. We are using next, okay. And our response. Okay, perfect, okay. This will allow us to do our middleware, or middle layer. I thought we were gonna have to do this, but we have to do this immediately. Auto heal, yeah, there you go. Thank you for the hearts, you guys. You're the guy learning from said. First we'll learn X HTML request. Oh, I know, right? Yeah, I remember those days. I remember those days. Note it down, big thanks. Hey, Ruchi, absolutely. You built a really good agent. It was really good, like it's solid. It's solid. I just had some code tidiness things for you to recommend. What's happening here? We are building a retrieval augmented generation in Rust using a variety of tools. We have got the plan right here. Right here, you guys. Oh, it's the plan. This is the part we're working on right now. We're working on the web server Axum Tokyo. This part right here. And then we are going to add a vector store with Turbovec. We'll add our SQLite database. We need to get our LLM. We didn't decide on what that's going to be yet. Probably one of the studios, the Premiere Studios. And then we need our embedding, which we haven't decided on yet. We might build a user interface so that way you can cleanly add new documents and query them. That's the plan. Oh, how's it going there? Niranj. Hey, Niranj, thank you for joining. You joined the right channel for software engineering. Good to have you here. We're working on it now. We're making our way. Which operating system? Which one? Let's see here. Okay, so, because he said you should study some legacy code. Oh, yeah, okay, and mobile too. Okay, yeah, that's fair. I mean, it kind of helps a little bit. You definitely want to know the modern way to do things, though, so be careful. If you study legacy code, you will find the wrong and old way to do things really quickly. So do be careful. Do be careful. All right. So let me see here. We want this middle layer to go here. All right. Close that out. There we go. All right. So we've got our extension. We got another layer there. You know what? We probably could put this at the end. Yes, we'll put that at the end. Okay. Okay. And let's see here. Don't need that anymore. Grab this up here. Make it a little bit easier. Get our things up there. All right, it looks good. Like the var and all. What's this going to do? This is going to be able to ingest large amounts of data. Large documents, small documents, and search them the way Google does, right? So you can search the data. BM25, vector search, full text search, right? Rank them. And then we can put that data into an LLM to answer the user's prompt, basically. So you can see here, for example, the user has a prompt. Here's the user's prompt right here. The user's prompting, what are the restricted LLMs that we cannot use due to compliance, right? That's like a prompt, for example. So we'll have a bunch of documents that in our database right here that will have that data, that information. And so our goal is to create an indexing engine that can safely find that and have an LLM summarize it. So it's basically like Google search, basically. That's all it is. It's Google search when you do things like that. So you can see, for example, the AI gave you an AI answer. That's basically what we're doing. That's what we're doing right now. First programming language, C++, which was a mistake. You don't want to use C++ as your first language. I don't recommend it. Let's see here. One more suggestion. Can you build your own authentication system from scratch in Rust? Yeah. For your website? You sure can. You absolutely can. It depends on how you're going to authenticate. You need to authorize and authenticate, right? You need to have user identity. You need to have user identity. You can do OAuth as well, right? You can just do OAuth. That could also work. All right, so force JSON content type. Okay, line 25. Right, we don't want that. Okay, post defined multiple times. We can take care of that. Where is this post? Oh, right, okay. Let me see here. Axum, we got routing post already. We need middleware. Do we have router? I don't know if we have router. We do, okay. We need middleware though. So let's grab that. Okay. Good now, almost good. All right, 49. Middleware, annotation needed. Does it want more, why? What does it want here? Cannot infer type of new error declared? Into new error, no. Layer, no, I don't think we have to do this. All right, we're gonna have to figure this out. Let's see. Okay. Maybe we can bring, maybe we want it the other way around. Yeah, okay. Duh, we figured it out. There we go. Quick and easy. Hey, how's it going there, Arsa? Arsa, good to see you. We're doing good. Thank you for asking. Yo, bro, how are you? Yeah, thank you very much. Good to have you here. Your first language is basic. Oh, basic. And then PHP. I remember PHP. Oh, yeah. It's like hypertext preprocessor. No, that's something. No, that's HTML. No, hypertext preprocessor, right? What does PHP stand for? PHP stands for hypertext preprocessor. Hey, look at us. We remember things from the past. Bunzupi, we shared similar experiences. Added you give command of build UI prompt. It will build and heal itself with vision instead of reading the code. Yeah, that's a good one, Rushi. Yeah, I like it. Can you give command of build? I added you can give command. I actually don't know what you're saying, but I like it. Rag system does use model locally or in cloud. You can do either. You could do either. You could do a local one, and we probably would be better off if we used a local one. We could just have, we could get Olama running, right? We could do Olama and have it run locally. We could do that. You guys want to do that? All right, that might be your answer. We could definitely do that. Okay, so for this right here, let's make it. Let's give ourselves the answer. So right here. So we will use Olama. Here we go. Olama, and we will call it probably like Gemma 4. We'll use Gemma 4. It's one of the best right now. Open source and clean and easy. PHP Laravel. Yeah, there we go. There we go. Olama would be good for serving the embedding as well. Stephen, oh, good idea. Oh, Bunzupi, you're using intelligence over there. All right. I like it. All right, so we'll do this Olama here as well for embedding. Hey, Bunzupi. All right, you're making my day. You're making my day so good. So good. Okay. Your cursor shows the same windows. Mac, yeah, we're running Mac here. Your cursor like same windows by your own Mac. How? What? Let's see. You have a laptop Ryzen. Ooh, nice. 4050. 32 gigs of RAM. Wow, billion parameters should you use locally? Yeah, I mean, if you can, you might as well. You might as well use it locally if you can. It's the same regular LLM for embedding also. If you don't want to serve separate models. Oh, you can. How can you do that? Can you do that? Really? I didn't know you could do that. So Bunzupi, tell me more. You're saying if we use the Gemma 4 model. Let's see. Where's our laser beam at? How do we do this? Laser pointer K. Okay. So you're saying if we use Olama with Gemma 4, we could use the embeddings from Gemma directly without loading another model. How do we do that? Do you know? What PDF that you are talking about, you learned about LLM? Oh, someone was saying that they did that. Emo, hey, Emo Boa! Welcome back from the last stream, good to see ya! Happy Sunday, good to have you here. All right, so where are we now? We got our middle there. Now I should just be able to run this, right? No errors. Yeah, there we go. Look at that. Oh, we got our web server running. Oh, it looks so good. It looks so good. I like to see that. Oh, it's so satisfying. All right. Say text, say, hello. Save, reload, and we should see a nice hello right there. Look at that. Right there. Which are some rag apps I played with. Yeah, but it's a lot heavier. I'm not sure what the details are. Okay. Got it. All right. Yeah, I don't know either. I've never done it. I assumed that the model was fully connected, and when it compiles, it has the embedding layer baked inside of it. What? Is it gonna allow me to grab those embeddings? I don't know. Maybe. PDF. All right. So, yeah, someone was talking about a PDF that taught them transformers and large language models. Okay. So now that I've got my web server going, I need the data. I want this. I want the body. Print. Let's see, let's do print ln body. Can I do that? Is that something I can do? Will it be happy? It doesn't like it. It doesn't like it. Why not? Why not? Let's see. You might be missing. Oh, sure. Okay, fine. We can do that. Not a big deal. Here we go. Regular body print. Okay. Okay. We should also see a hello. We should also see. So it should be hello, hello, right? Top and bottom. Here we go. Top and bottom. Hello, hello. Right there. There we did it. Okay. So now we can do like a bunch of exclamation points. You'll see it pop up there. Nice. All right. Get status, get add. Oh, wait. Let's see. RM agent, get add. And second, get status. We did it. All right. Get commit. Web server ready to go. All right. Push it to main branch. Definitely not efficient because you're having to load the baked embedding models of all the weights. I'm just saying it's possible. I don't think it's necessarily an ideal. Okay, unless you really don't want to serve a separate model. I don't. Yeah, there's no big deal. I've got plenty of memory. We got plenty of memory. Right here, you can see plenty of memory right there. Right? A little bit of memory. Just a smidgen. Just a smidgen. More than we need. Okay. So, we have succeeded with our web server Tokyo side of things. I'm very happy with where we're at. I would also like to add another route for ingesting data. So I'd like to be able to ingest the data. So this is our root, which is our prompt. This is the query interface. Query interface for user prompts. Right there, right? Hey, Karthik, good to see you. Welcome on in. Happy Sunday. All right. And I can get my body. It would be nice to be able to extract the text from the JSON. So, do we know how to do that? All right, so let's see here. Axum. Let me go back. I have some data. Yep, looks good. All right, body. Create body. Is that it? How do we extract? All right, let's do a quick little Google. Extract text field from JSON body Axum Rust. See how we do this. Look this up really quick. Is there an extract? Do we need to do extract? Right? Deserialize. Payload text. Oh. I see. Okay. That works for me. It's just a regular Serde value at that point, right? Okay. So let text. And this will be, can we do and stir equals body text, all right, dot as stir, and then we need to unwrap or. We'll say no prompt. We'll just say empty string dot toString. Do we have to say dot toString? Do we have to? I don't want to say dot toString. I just want to reference it. Let's see. How about that? Doesn't like that. toString. Let's see here. 1 second. Oh, okay. So that's why it's returning a string. Okay. Let's see here really quick. Here we go. All right. You have 16 gig of memory and 4 gig of VRAM. Oh, Bonzupi. Well, you are constrained a little bit. However, you should be able to get something running there. All right, so I made a mistake somewhere. Here it is. Okay. How about this? There we go. I thought so. I thought so. Excellent. Okay. So I've got my text. How will we call this the prompt? Call that the prompt. And then we will say user prompt. User prompt will be the prompt. There we go. Prompte. Perfect. Reload. Run our server. All right, user prompt hello. Perfect. That's it. And you know what? I should probably also just make it the word prompt instead of text. Let's call this prompt. Prompt. And then instead of sending text, we'll send prompt. Let's see. Prompt. Should be empty. Yep, looks good. Then we do a reload. And we got our prompt back. All right, good. Perfect. Hey, how's it going there, Gray Like Yeah? Welcome on in. Thanks for saying hello. Good to have you here. Install Python docs. What does this creating docx and PDFs also? Oh, probably. I assume so. Gray Like Yeah. Hello. Do you me? Hello. Yes, we do. Yes. Good to have you here. Okay, so let's add the next post route. Let's do this. Yeah, let's add another post route. And this will be for our load doc. So we'll do a doc. All right. Let's see. Yeah. Grab this as well. Let's call this a doc. We'll return success, a success JSON message here. What do you call this? I'll just say success. All right. Doc loaded successfully. Okay. Good. I like it. Where is it saying I got a problem though? It says I got a problem. Where's that? Oh wait, we do need to say like add. Maybe we say doc. We'll do doc. Doc. Perfect. Okay. So it's getting a problem here. Wait, why is it? Oh. Right. Okay. No. Yes. Route. Oh, weird. Hold on. Hold the phone. One moment. What is going on here? This is weird. Okay. That's better. Okay, let's try this. All right. Okay, perfect. Okay. I would like to create a quick little, an integration test. We should build an integration test. Do you remember me? Oh, hey, Trevor. Barely, kind of. I might. Hey, I remember Code Mitsu. Wow, Rag is awesome. Hey, Code Mitsu. People have been asking for it. So yeah, we gotten started. Rag Day 2. Yeah, so Gray Like Yeah. I should remember. I'm sorry. I barely. I have like maybe just a smidgen. There's a smidgen in there. Just a smidgen. But Gray Like Yeah, it's good to have you here. What have you been up to? Have you built any? What exciting project are you working on? Tell me about it. What exciting project are you working on? All right, so we need to add our tests now. Let's do this. The boring part, deal with that. All right, so we're gonna create a new directory, mkdir tests. All right, and then we're going to open up a file here, tests, itest.sh. All right, so this will be shebang user / bin zsh. Okay, then we need to say curl http:// see payload prompt. We'll do like a prompt here. Prompt prompt equals hello 000. Oh, we should say host. Host equals bunch of zeros and 3000 for the local. Curl money host / dash D. Then our prompt, we need to have our wrapper. So we're going to say JSON here. And I want this to be the prompt. There we go. Money prompt. Like that. Except we need this to be like that. Okay, so we get the prompt going there. Hello, how is it going? Okay. chmod plus X test. Tests. I test. Yeah. chmod. Oh, I typed that wrong. Here we go. mod. Perfect. Okay. / test. I test. There we go. Testing's happening. All right, we got our I test going. We also should do a doc as well. Doc. And this will be text. Call this our doc. Document. There we go. Day is going well. Thank you. Really simple document. And then we will say the text will be like a document or something. Oh, how's it going there? Pieth Crank, good to see ya. Welcome on in. Steven, your IP address is showing. I know, right, Bonzupi? Hey, that's everybody's IP address. Everyone's got the zeros. You're trading logistics regressions, L2 regularization, and implemented Fourier future FFT Fourier something Fourier transforms. What is FFT again? Fourier transforms. FFT transforms. Fourier fast Fourier transforms. That's what it is. Fast. Dr. Smith, boy, thank you. Thank you. Appreciate it. Learn how to build models from scratch. Yeah, there you go. Fast Fourier transforms. Nice. Kodemitsu. Excellent. All right. Let's do this. All right, so test document loading. Test basic prompt. Okay, looks good to me. Okay, now we got our test. Git status. Git commit. Added doc. Let's see, / doc. And tests. Push domain. Boom, done. Okay. So we've got our basic tests, and then now we get on to the next step. We're running here. We're running. Okay. I'm gonna put a green check mark next to the things that we have completed. See, routes, web server routes. We got those. All right, looking good. Okay. All right. So what do we want to do next? We've got several pathways. Hi, bruh. Good to see you, Mohammed. Welcome on in. Happy Sunday. Good to have you here. We got to decide what we want to do next here. Do we want to do embedding, Turbovec? Well, I mean, we can't really do Turbovec until we have the embedding, right? So we do want to probably run that on a llama, maybe? Yeah. Best way. Okay. Which is the best to train any AI? Please, I want to get a better answer. All right. Yes, I'm happy to answer it. Before I do, though, your question's a little bit broad. What are you trying to do? Are you trying to learn how to build AI algorithms? Or are you trying to train an AI model that already exists? Or are you trying to do fine-tuning? Retrieval Augmented Generation. Yeah, Karthik, yep, you got it. Question lacks specificity. It does. To train AI, are you training the AI you already know? It sounds like you want to learn the algorithms. My recommendation, if that's the case, until you answer, if you type in your text there to let me know, is to start with something like linear regression, something really simple, really easy. So you fit a line over data points, a binary classification. Right? That would be my recommendation. Then you could upgrade to an SVM, so you can have higher dimensionality, right? Then you can do your own deep learning model, your own deep learning from scratch, maybe, or use a framework, right? My recommendation is do it all in Python. because you won't have to deal with the syntax struggles of things like Rust that we got going on here. Like a lot of Rust here. There's a lot of problems that you can run into easily. All right, let's clean up our code. Close this. Did I save? Yeah, okay. Close that. Okay. So this is the user prompt. This is the uploading upload more documents. There we go. User prompt. Then we've got we already know what that is. We know what those things are. We don't need to comment those. Thanks, buddy. You're welcome. Good to have you here. Glad you asked. All right, so we probably could get let's do SQLite next. Let's do SQLite. Because then we can skip these guys for now, and I think SQLite is a good answer for the next part of it. We're gonna build in a database, embedding a database. You guys, have you ever done that before? Have you ever built with an embedded database? Let's see. All right. Have you ever used an embedded database before in code? Yes, no? All right, curious about it. Yeah, I'm expecting some yeses. Maybe a few yeses. State could be const. Wait, user, what do you mean? App and state could be const. Can they? Can they? Well, they're already immutable. They're already immutable. So Rust is immutable by default, right? You say let const. Can you do that? It doesn't like that. It's not happy about this. Const. I don't want it. I don't want it. User, tell me more. Give me the right syntax. Might be right. Vimp is safe because you don't touch much of the machine. It work in a virtual environment, so system files will be untouched. Yeah, always a good idea. Always a good idea, I think. Replace let with const, I think. Const, that's right. Redo. Save. Const. I forgot about that, Bonzupi. I forgot. It doesn't like it. Missing type const item. Is there a const in Rust? You know, it's been a while, so Google const in Rust example. Let's find out, you guys. Let's see what we got. Okay, so it's gonna be like a global like this. Const, data type, good to go. I've seen that before. And Bonzupi, you're right. This is the exact syntax. Though for our setup here, const doesn't seem to be happy. Missing type. So this will be, we have to say arc rag like that. Then it's happy. Cannot call non-const function. Oh, okay. All right. It doesn't want me to do it. Let's see here. Can we do it now? Yeah, okay. So we can do this. I love your live streams, bro. Oh, thank you, Code Mitsu. They're very informative and teaches on the fly through trial and error. Yeah, there we go. That's the best way to learn, trial and error. Trial by fire, you guys. It's the way to do it. It's the Ronan. Hey, Ronan, good to see you. All right, so you're working on an NL2 sequence, natural language to SQL program. Oh, no way. Hey, that's amazing. You want a query to be constructed, right? You want a query to be correct, business sense wise, also part of being technically correct. Any success? I built this. Yes, I built this. I used an LLM though. Is it probably cheating? I think it's probably cheating. I did use an LLM and I gave it all the schema and everything, and it automatically generated the SQL for me in an agent. Hey, Blade Z, good to see ya. Yo, welcome on in. Happy Sunday. Good to have you here. See if I add new feature in Vim open source GitHub, then also loved by Vim officials. Then I can get hired. Ruchi, you can get hired right now. You just might want to focus on a job that you could get hired for more easily that has less competition. Use the trick, you guys. There's the one trick that's worked for decades. All you have to do is get a foot in the door job. a role. That's what I did. Get a tech support role, right? And that tech support role might be at a company that has engineers. And one day you might be able to get your engineering role by having experience there at that. So that's the way to do it. And you know what? I understand it's not ideal. You might not want to do that. Well, good news. No one else is either. It's the way in though. It's the way in. It works. I've done it before. What are you actually building right now, Mohammed? A Retrieval Augmented Generation server. So we've got all these components here. We currently finished the web server side of things. Now we're going to add our SQLite database. So that way we can add documents. That's the part that we're going to do right now. We're going to do this part right here. We're going to add in our database right there. Okay. Let's see. JEPA. I remember JEPA. Let's see. JEPA model. Joint Embedding Predictive Architecture, an AI framework developed by Meta. Instead of generating exact data like pixels or text, it builds an internal model of the world by predicting abstract representations of missing or future information in a compressed latent space. So then it can like do completions. Is that what that is? Is that what that is? So cool. That's pretty cool. I like it. All right. Crank, you're saying, do you have any thoughts about the JEPA and world models? Oh, right. Lechen's suggestion recently. Here we go. Laccoon, right? I have not played with it. I do not have any insight on the matter. Storing embeddings in SQLite. So we're going to be using Turbovec right here. So we'll be using Turbovec. So that way we can do database full text search BM25, right? And then combine that with Turbovec. So we're going to do the double. We're doubling it up. So we're going to start with the database first, and then we'll augment with vector store, which is, hey, there you go. It's what everyone's talking about when they're talking about retrieval augmented generation. There's always some sort of vector store in there, right? Always some sort of vector store. Okay, we achieved our main objective. Let's move on. So I want to do this part next. Noted down, pal. Root sheet, good to hear. We could store, because there is a vector index in SQLite, so we could do that as well. We could just go straight there. The vector Turbovec, a little bit faster. Oh, I thought you were doing some rookie mistake. You did it. Oh, you thought you were doing some, oh, well, yeah, I mean, we could have easily made that mistake. I just tell stories. I saw your message only briefly. I saw it there briefly, and then you redacted it. You took it away. Okay. Go here. Let me run our tests. Let's run our tests. All right, looking good here. Yep, looking good. Data testing good. Okay. So let's add our RAG state. Our RAG state needs to have our SQLite. We need our RustQLite here. All right. So I think I had details of that around here somewhere. Did we grab this? Here it is. No, that's Turbovec. I want RustQLite. Here we go. All right. So we can store our connection. And then we can save the person. Ooh, we can create a document structure. I like that idea. All right. A doc structure. Perfect. Have you tried Terso? Oh, Rock. Yes, I have. I've used libSQLite, right? libSQLite. It's called libSQLite, I think, right? libSQLite 3. Maybe was it libSQLite? Terso. I've done it before. libSQL, it's a fork of SQLite. Yeah, libSQL, right there. Yep. I've used it before, so the answer is yes. I've tried it. Rockin' Brain, nice. Using plain old SQLite. Yep, plain old SQLite, you got it. I wanted to embed the new, what is it called, Nemo or something, right? No, Limbo. It's called Limbo. The SQLite replacement, or the rewrite, really. It's the rewrite of SQLite in Rust, created by Terso, Limbo, right? I wanted to use that in Rust, but they didn't have any good instructions. They didn't. They're like, oh, you want to use this here? You want to use this in Rust? Yeah, you do? Yeah. Oh, sorry, you can't. Nope. We're not going to tell you how. No. Nope. Not gonna. Nope. It's written in Rust. It should be Rust native. Right? Limbo Rust crate. Right here. Look, empty. It's empty. See? I want to use it. They're like, nope. Sorry. Not gonna let you. Didn't think you wanted that. Nope. Oh wait, there's an option right here. Hey, look at that. Oh, all right. Well, you know what? Since you brought this up, I just didn't click the right button. All right, it's right here. All right, let's add it. It says Terso. So, oh wait. Oh, it's not what I want. I want to use Limbo, not Terso. Oh, okay. Don't know if this is the right thing or not. Can you tell me the name of your chair? Yeah, this is the standard chair that you get from Amazon, right? Let me get this here. So Amazon Basics chair office chair. Amazon Basics office chair. Yeah, there we go. It's one of these in here. Let me see if I can find it. Is that it? I think that might be it. Right here. Is this it right here? Is that it? Yeah, that kind of looks like it's it. Yeah, I think so. I think so. Amazon's Basics Classics chair right here. Yeah, it's a really good regular price chair. Simple. It's really easy. You too can have this very chair if you wanted it. You have to put it together. Yep. It's basically, yeah, this is the right chair. That's it right there. Okay. You think Terso is supposed to have a native vector database feature that plain SQLite doesn't have? Yeah, I think SQLite does have SQLite vector index. I know it does. Because they added it a year ago. SQLite vector search can be achieved using native SQL functions for small database lightweight extensions. Let's see, SQLite. I used it. I tested it out. SQLite create function, cosine similarity. Yeah, see, you can query with cosine. Right there. I don't know if it's a full table scan though. I'm not sure if it's full table. Ruchi, bye pal. All right, sounds good, Ruchi. Good to see you today. JEPA models basically understand the world, current methods, and next token prediction. Basically a model that understands rather than one that only predicts the next token. So it's got an understanding. Yeah, I think it did like a loop, an internal loop, input. But the transformer does that too, through number of blocks. You stack your blocks, your head, you got your blocks, and you loop over it. So maybe the JEPA does something a little bit different with that internal loop. Hey, Seif! Good to see you. Something special basic model should learn in Python. Yo, I want to ask about something. What do you, that is basics. Okay. What are you asking? Let me know. All right. Rag, we're going to need our SQLite here. All right. This is not the one here. Nope. Yes. All right. So we're going to want a connection. All right, here we go. Use SQLite, and we're going to need our params, connections, and we don't want the result. We can't do that because we've got an anyhow result, and we don't want to import that and pollute it. So that would be a problem. So we want our connection. We're just going to call it a connection. You know, how about we just do this because we're not going to be using it too heavily. So we will do this. So we're going to say our database is going to be a SQLite connection. That's what that is. There we go. Let me load this. It's going to say, uh-oh, database field missing. We're going to need to add it in here. We're going to create a new connection, a new rag state, and this is going to be our database. It's going to be a SQLite. We're going to create a new connection. Open. We'll do open in memory first. In memory. Right. Question mark, colon. Okay. Comma. There we go. Good. Uh-oh. We got a problem. Got a problem, you guys. Here, let's close this really quick so we can see more of our screen. Get more of our screen going here. All right. So it's saying that it doesn't like it. It's saying it's not happy about this. Connection open in memory. Maybe I typed this wrong here. Sometimes I do that. No. Unwrap. Try that really quick. Nope, doesn't like that. Okay. So what is our problem? Oh, did we mess it up somehow? It's saying that something else is broken. Unsatisfied trait bound. Required by bound to introduce this call. What does it say? Handler. Why is that doing this? Hold on a second. Database. All right, good to go there. Okay, good. You're interested in learning Rust? Hey, excellent. Still learning JavaScript. All right, JavaScript is great. I think JavaScript's a great language. I used it a lot. It's a lot of satisfying. I'm not sure it's worth the hour right now. Always worth it to learn something new. Hey, Ali, good to see ya. Welcome on in. Thanks for saying hi. What should I learn in modules of Python? Scikit-learn. I like Scikit-learn. Do scikit-learn. I like that one. That one's a fun one. There's also matplotlib, but it's fine. It's not my favorite, but I'm fine with it because it's not terrible. I've used it a lot in the past for real production systems. So those are good common libraries that you'll see in industry. Of course, you get to PyTorch, right? Or libtorch. So there's also Torch, though that's going to be more advanced. Be a bit more advanced. Okay, so I want to store that there. So what we're going to do is we're going to say let db equals SQLite connection open in memory. Do we need to do anything else there? No. Question mark. So that's work. That's there, right there. That seems to be happy. That seems to be happy right there. So if we undo that, call this a connection. Now it's going to get this like missing field database. All right. So we'll say database and then DB. We say an address of. We do that. So we say a reference to. No, because it wants a lifetime. All right. How do we do this? You okay? We are? Okay, TY. Excellent, excellent. Should one go to JavaScript first and then TypeScript, or go to TypeScript straight up? TensorFlow. Oh yeah, there's another one. TensorFlow is a good one, yeah. I recommend JavaScript, then TS. Yeah, that's a good idea. JS first, TS. That's a good recommendation. If you pursue the knowledge for the sake of knowledge, then learn something new is always worth the ROI. Bonzupi quote. Hey, Krishna, good to see you. Welcome on in. Happy Sunday. Good to have you here. Love from India. Hey, excellent. Good to have you here. It's 10:05 p.m. where you are there in India. Hope you're doing good. It is 9:30 in the morning over here. 9:35 in the morning. We are in Seattle, Washington. Yes. Nice. All right. So I've got my database here. I'd like to be able to store it. I want to store it. Handler. It's just a rag state, though. It's just the rag state. It's right there. Right here. Right there. It's fine. Arc rag state. Right there. It's the same object as it was before. Maybe we need to. Is this how we do this? All right. Are you a freelancer? Oh, sure. All right. So thank you for asking. My name is Stephen Blum, co-founder, CTO at PubNub. We updated this yesterday because you guys asked for it. You're like, hey, why don't you add that right there? Yeah. So we raised 134 million, Series E, 1 billion devices on my network, right? I always show a phone because that is a device that's communicating with other devices. 68 patent claims that you can see on my LinkedIn profile. It's legit. You can see it right there. It's in Google patent search. Let's see. Can I get a job in abroad as data analyst? Yes, of course you can. Of course. Absolutely. That's definitely something you can do. They might have a little more challenge in some cases because a lot of data compliance is a barrier, right? And so they typically want you to be in the same country sometimes. Wow, man, thought you were a random YouTuber. Hey, yeah, well, we're that too. We're also a random YouTuber. You could say that. Yeah, we've been doing this for over a decade now. We're doing PubNub. Let's see here. Yep, got some PubNub going there. We do communications APIs for the world. We've got a lot of tech, a lot of businesses running on us. Thanks, Brown. Very poor. Even bought 8 gigs. Oh, 8 gigs is gonna be expensive. $300. Wow, that's a lot of money. That's a lot to spend on hardware, especially when you used to be able to buy a whole entire computer for that. Okay, where are we now on our time? All right, we got about. Okay, bet. All right, good to hear. Let me see here. What do I want to do? I really wanted to get my ARC rag state. I wanted my state. I want my rag state. I want it. I want the rag state. I need it. I need it to be there. When it's empty, it's fine. When it's empty, it's fine. But when I add the DB, it's not. So, what if we did something simpler? Like we said, it's a string. Okay, and then when we create a database, we do something like this. Hello. .toString. Good? Okay. So now we've got more details. Now we know that part works. Okay. So we're gonna need our SQLite. We're gonna call it SQLite. Is what we're gonna do. Call it SQLite. Here we go. Paste. And it's going to be a SQLite connection. And it might be possible that we just simply needed to do a little simple thing there. Hey, Derek, good to see ya. Watch the Rust videos up to the borrow checker. Oh, no way. Nice. That's great to hear. All right, Crank, you don't understand, Steven, how you manage to stream so regularly as a full-blown CTO. This is my free time, you guys. Yeah, I'm using my free time to stream with you. Also, we're being, I'm being productive at the same time. We're learning new things. As part of my job is I need to be aware of everything. I need to know as much as possible so that I can help my teams be successful and work with our customers, work with our staff, and our engineering, any interactions with customers and our marketing. That's a lot of stuff. We got to do a lot of stuff. So you're helping me. I bet you didn't know. You were. Appreciate first time foreigners YouTuber talks respectfully after knowing I'm Indian. Oh, Krishna. Yeah. That's great to hear. Absolutely. We have a lot of scanned geological maps. Need AI that looks at those maps. Ooh, computer vision. Knowledge and vectorize. Yeah, high resolution satellite images. Yeah, so you probably want to do standard CNN or vision transformer. Ooh, do a vision transformer. Hey, vision transformer. There we go. I like that. A lot of videos in your channel sequence to watch, them with no documentation to follow through. A lot of videos on your channel. What sequence? Oh, well, I do have some playlists. So, Steven, Tub, you go to playlist here. Look at the playlists. So these have order. I did some order on these. Some, not all. What's your advice for new people in tech? Learn on your own. Learn by writing the code by hand. You will have more knowledge than anyone else. And the big thing is you need to make mistakes, right? You need to make mistakes and fail, because your failures are what's going to give you a foundation of knowledge. Beyond someone who's just asking the AI to do the writing for them, they'll never understand what doesn't work. And if you know what doesn't work, you'll know the system better than anyone else. That's my advice. Okay. Where are we here? I want to figure out why this isn't working. And it's possible that we need to do something different here. Self. Do self, comma, connection. It's possible we need to do that right there. Probably. Oh, is there another one? Hold on. Wait. Where are we? Yeah. No. We knew that. I want to use here. Is this it? Where are we at? Let's see. That's Todd. All right. No. It's around here somewhere. Not that. Where was it? Nope, not this either. No. All right. No. All right. Rust. I want our Rust. Here. Is it right here? No, not that one. Okay, we're gonna type it again. Okay. SQLite. Great. Let's just go back to it again. Okay. So we got our connection right there. Oh. Ow. Okay, I see what's going on there. All right. That's why. Okay. I see what it's doing, because it's not using an anyhow, it's using a SQLite result with the question mark right there. That's the problem, you guys, right there. Do you believe in astrology? You have a few clients in California. Krishna, I don't really think about it. I don't have a belief one way or the other, and I just don't even think about it. It's not even on my mind. I don't even think about it. How to use AI to learn things? My recommendation is just, at the minimum, if you're going to use AI, use it to help ask a specific question, like looking up docs. If you're going to look up docs, like for example, right now I'm looking up docs, and I'm reading the docs, and I'm understanding the system. See, and I just found the problem because the result is a different kind of result. So I need to think about how to deal with that, right? Instead of using a question mark, which I cannot do, I have to do something different. So the answer is something different. All right, so we know that works. We're happy with this. So we'll go SQLite, and then we need our DB, and it cannot be a question mark. We need a match. Let me do a .expect. Let's just do unwrap for now. Add a to do fix. Remove unwrap. DB. Okay. Bring this back real quick. Here we go. Okay. Then we also needed param. Do we need param or anything like that? Let's see. Do you practical? Wait, you doing practical coding live keeping? Yeah, motivated and gets us overwhelmed. Hey, yeah, we are. We're coding by hand. This is the old way to do things. We're doing it the old way, you guys. How many tabs do you got open there, bud? Oh, a lot. I've got a lot. Can you see how many tabs I've got? Let me see here. Can you see? Oh, you can't really. But yeah, I've got a lot of tabs. Here, I'll give you a hint really quick. Yeah, you want to see? Look at, this is just one window. There's more tabs than other windows. I got a lot of them. A lot of tabs. All right, any advice for someone who wants to learn hardware? Oh, with software background. I don't know. I mean, start with a microprocessor, though you have to program that. You want to learn the different components, resistors, transistors, obviously the capacitors. There's a whole bunch of different things, right? And you want to build your own. So get a breadboard, right? Breadboard, maybe a breadboard simulator. This might work, right? So you can grab your diodes, your LDRs. You have an infrared emitter and a detector. Oh, look at that. That's so neat. A battery, DC motor. This is pretty neat. I don't know how to use it though. Click. Let's see, click here. How about this? How do we? Well, I mean, at least you know the components. So yeah, there's a lot of options here. I would say a breadboard is a good start. Cannot just see you flying through 20 of them trying to find the SQLite talks. Oh yeah. Yeah. Okay, so that's how you saw. Got it. Understood. So this works here. If that works, and I can get the DB fine, then let me also do a question mark there. So I can do that. That works. What if we did this? So it's letting me do this here. Right, we call it whatever we want. Okay. So I would like to be able to access that DB inside my RAG. That's what I want to do. That's the thing I want to do. Oh, hey, Don Moggs, forever. Oh, thank you. You're super nice and have a good soul. Whoa, thank you. Thank you so much. Dawn, thank you. Exclamation point party popper. Whoa. Thank you. My gratitudes to you. You didn't have to do that. We're just software engineering over here. We're writing software. We're writing code. I appreciate it. Oh, you're so very nice. Oh, I forgot to click the send button. There we go. Thank you very much, party poppers. I appreciate you. That's so nice. Well, just thank you again. All I can say, thank you. I appreciate it. That's so nice. Wow, you guys, look at that. Where else on the planet does people just like, hey, here you go, here's some money, here you go, boom? It doesn't happen. If you're walking around on the street, typically that doesn't happen. It just doesn't. It's like, oh, hey, here you go. Well, thank you again. I appreciate you. Does the breadboard simulator simulate the blue smoke? Oh, yeah, Bun Soup. Yeah, I don't think so. I mean, a new simulator probably would. Using a new one would. All right. Okay, so we need to figure out how to get our arc state here. We need to figure this out. We have that here. What if we call this just a connection? See, now it's giving me problems. Because it's supposed to be able to take the RAG state and just do whatever I want with it. Whoa, look! I'm in the docks. There we go, right there. Okay. Look at that, you guys. SQLite. And this is also SQLite. Okay. So we got both of them there. Okay. Let me close a few tabs here. Close a few tabs. There we go. Now we got both of them. All right. Let's go back to Axum. Now let's look at our arc. For arc state. Arc state new app state. Yeah, that's what I want. Then we say state. Wait. We got something weird here. Look at this. All right. Did I do this properly? Extension. It's called extension here. This is weird. Right? For here, it's called state. App state, arc, and state. We're doing that differently. Here. Extension. Handler. Extension, arc state. So we're doing it this way, which I like better. Right? We've got our app state here. Extension shared state. Shared state right there. Yeah. Oh. We should, I guess here, we are doing it differently. Are we though? No. We've got our state arc and our state arc new. Right here, arc new. I mean, we can get rid of this. We don't need, that part's optional. Okay. Did that change the error? No, it's the same error. Okay. All right. So arc new app state. Yep. Basically is what we got here. Right? Let's close that out. All right. Rag state. There we go. And then it looks good. Everything's fine there. Extension. How do we get our state back? State. Is there an arc in here? State, arc, state. Is that a problem? All right. So we have to figure out how to solve this right here. This is the thing that we are currently probleming over. Okay. Arc. Let's look for state. App state. Sharing state with handlers. This is what I want to do. Using state extractor. Using request extensions. Extract state. Do I have that defined? I do not. I have extract extension. Extract extension. State, state, state. Arc state handler. With state. Oh. Oh, hey. Hey, maybe we should do it this way. With state. Let's try this. All right, so we've got another option here. We've got another option. So I'm using this right now. We could do it differently on this. Route, then with state, shared state. Okay. So we could do this instead of this. We'll call this state. And we need to import state. Is it called extract state instead of extension? Here we go. Let's try this. State. Undo, undo. Next. Here we go. Right. Let me do state, state. State, arc, state. There we go. Looks good to me. Okay, right here. Good. Oh. Okay. It likes that. Now, we just have to see if this will work. Is that going to be good or not good? Same problem. It's the same problem. The good news is, though, it's a little bit cleaner. Just a smidge cleaner. Resize. Pane. Up 10. So we can see a little bit more here. Okay. So, unsatisfied trait bound post required by a bound trait by this call. Required by this trait bound post. Post. Consider. What are you doing? Hey, how's it going there? Talking bats. Hey, talking bats. Talking bats. Good to see you. Okay. We're building a retrieval augmented generation engine. It's going to be able to store documents and retrieve segments of those documents. So that way a large language model, when you ask a question, a user prompt. Here we go. This is our plan here. So a user asks a question, right? A user say, hey, what are the restricted large language models that we cannot use due to compliance? That's like a question. So we will be creating an engine that can answer that question. So it's a normal human prompt, like a human asks a question, natural language. And we're going to convert that natural language prompt into something that can actually be answered based on the documents that we have. This is kind of how like Google works. Okay, nice. Hey, Rebellion 9, good to see ya. Welcome on back. Good to have you here. We're building a RAG because you guys asked for it. You're like, hey, we need this. I'm like, all right, let's do it. Unsatisfied trait bound. Yeah, I get it. Just, it's not telling me exactly what I want to do here. Oh, ref call cannot be shared between threads safely. Oh. Okay, so what should we do about that? I've done this before. I know it's possible. This is helpful. Yeah, thank you. Good to see you too, Steven. How's your Sunday? Sunday's good. Good Sunday so far. Thank you for asking. Thank you. Oh, right. Okay, so I do have the answer, I believe, I think, maybe. We need to do some sort of sync stuff here. All right. Clone required by this trait. The thing is, I don't know. Oh. Can we do a macro? You guys think? Thank you for the hearts. Appreciate it. Thank you for all those hearts. Must be a pro. We're doing pretty good. Thank you for the hearts. I very much like that. Hey, Rock and Brian. What Rock and Brain? Steven, do you work with Rust on a daily basis? I mean, in your job? I used to work with it very, very frequently, and mostly my team takes care of it now, right? My team does. However, I've written Rust. I've done my own Rust. I've done it. So we are doing that now. We're building a RAG because you guys asked for it. Like, hey, we should build a retrieval augmented generation. Yeah. So that's what we're doing. Absolutely, you guys. Absolutely. This is helpful. Thank you. Kuna, thank you. Appreciate it. Thank you for the hearts, you guys. Thank you. I see these floaty heart icons right here. Right there, you guys. That's you. You're the ones who are doing that. You're doing it. Thank you so much. Appreciate you. Okay. We have to figure this out though. We have to figure this out. So rag state required bound S new router. We need send required. Okay. So how do we add this? I forgot. There's a way to do it. There's like a sort of like an annotation, right? We got to do an annotation. Thank you for the party poppers. Okay, goo Gemini here. Let's see here. Gemini. All right. How to add these to struct. Is agentic AI and building software for AI agents too saturated by now? Oh, using mutex. Ooh, Vincent. Okay. Maybe we're using mutex there. So, correct. Mutex. Oh, hey, look at that right there. It's right there, Vincent. Hey, look at that. So, Mohammed, I don't think it's not saturated at all. It's just the way things are starting to happen now, right? It's the modern approach. Man, your CTO using Gemini Pro. Yeah, yep, you got it. Here we go. Op state. All right, derive clone. All right, so we got to do a derive clone on this. Yeah, I think that might be part of the answer. Yeah, all right, derive clone. Thank you guys for the reactions. Do appreciate it. See, use Datadog. Oh, Splunk. Yeah, your boss. Not for knowing these things. Yeah, Datadog and Splunk are not hard. They're just data indexing engines. They're very simple. They're very straightforward. Derive clone. Do that. Derive clone. In this derive macro, do we have to say pub? Do we? I don't think so. All right. The trait clone is not implemented for connection. Oh, all right. Well, fine. Guess we can't do that. You said mutex, huh? Okay. So we've got our arc. We need our Tokyo mutex. Try that. Where's our Tokyo at? We've got Tokyo in here. Here we go. Tokyo mutex. All right. Use correct. Wrap it. Okay. My cache. Hold on right there. To me, this is pretty confusing. Talking bats. Yeah, it is. It is confusing. Don't worry. You're right. It is. It's confusing. Queries and priorities. They gave you 2 story points for that. I need to validate that and monitor the thing and staging and production. In staging and production. Okay. Pub cache. Ref cell is not thread safe. Wrap mutable data in a mutex. Okay. So it wants it in a mutex. Let's try it out. Here we go. So mutex. Okay. And then we need to initialize this. Arc, yes. This is what we want to do here. Shared state, looks good. Shared state, app arc new, rag state. That's what we're doing right now. This is what we got. Pub struct, app state, pub arc rag. This is a tuple, right? Pub struct, derive clone. Wait, we can derive clone now? Axum state needs to be cheaply clonable. Instead of deriving clone on rag state directly, create a type alias. Oh, okay. All right. Create an alias. Derive clone app state prob app state. Our rag state. Arc pub. Looks good. Okay. And then when we pass that through, we just create an app state out of it. Okay. App state for our arc rag state. Okay. So we would want an app state around here somewhere. Right here. App state. Like this. Right? We wrap it. Yep. db.into. So I don't know if that'll work. Into. All right, we're making progress. Little steps at a time. Steven, today read my comment about simulation. Oh, sure. Let me see what you said there. Where'd you at? Van Chick. Where is that at? Here, let me see. Let me go here. 1 second. Let me zoom out. Here we go. Okay. What'd you say? Hey, Steven, today read my comment about simulation. Hey, Steven, today I created a Phoenix Junta party set. It looks like it didn't show up. I don't see your message. I don't see it. All right, let me see here. How much time? All right, we got a few minutes left, you guys. And we are getting close. Let me go back to 0. All right. Channel activity. All right. Can AI take over jobs of QA, like manual testing, JMeter? Yes, they can, but not completely. So they're just tools. All of the AI systems that are taking over jobs right now, they're just tools that humans can use because you have to know how to deploy them. We don't have anything that's automatically taking away those jobs. Not yet. We don't have AGI yet. Okay. All right. So, where do we go next from here? Expected argrag state found app state. Okay, we can fix that with state. And it got a app arg state. Yeah, wait. Oh, because of this right here. Is this right? So this will be an app state. Is that what we want? So it'll be an app state like this. So I don't know if this is going to be what I want. I don't think this is going to be exactly what I want. Here, I've got an idea. Let's hide these. And then save. Okay. So that is the first time that we've gotten something that actually works now. So we're making progress. Let's see here. Okay. Expected arc rag state because we want the app state. All right. And then the app state is just a struct alias. So I'm not familiar with this approach. And I don't know if I've ever done this before or if I need to do it differently. So that means that I need to change this here. This is going to be changing here. Let's see here. Right here with state. No. We've got to change it here. It needs to be changed here. And so I'm just not exactly sure how do we do that. So this is app state, arc. Let me see if I can see this. It says app state. Like that. Here. Okay. Which is an arc new. An arc, basically it's this right here. Is that gonna even let us do this? I don't think so. Okay. Looking good. Okay, we are almost here. I just need to do this one little teeny bit part right here. Can we just call this app state? App state. Like that. Expected app state found state. Do this. Hold on 1 second. What do we call this down here? Yeah, state. Okay. State. Like this. Like that. Okay. Boom. There we go. There we go, you guys. All right. All right. We're making progress. A little bit of challenge. A little bit of challenge. So a database is a collection of data. That's right. That's a collection of data. That's it. And previously, you basically, anything that is a collection of data, you can definitely call a database. There's a few other things that sometimes come with databases. Indexes, right? A way to fastly retrieve the data that's in your database. Because when you do a search, you want to be able to search the data and find it quickly. Rather than doing a full scan across all the data, you could do that. It's just slow. So an index is going to extract pieces and ideas out of that raw data and create sort of memory pointers, really. Ways to quickly get to the data on disk. There are a lot of different kinds of indexes. You get your vector indexes, your full text search indexes, your B trees, your hash maps. You've got a lot. There's a lot of different varieties. I see it's not nice. Okay. So let's get close to wrapping up here, you guys. And I don't really want to go do the thing that I have to do after this. I have to go do some paperwork, and I don't want to deal with it. I really don't. Because it's not good news paperwork. It's weird paperwork. I don't want to do it. I want to do this instead. I'd much rather be here with you guys. I'd much rather be here with you guys. I got to go do some paperwork next. Okay. So, let's see. Yep, state looks good, Okay. So we got our app state right there. Our app state looking good. Okay. Scientific data. Oh, yeah, you can get some scientific data in there. Paperwork Turbo, let's build AI robots for that. Hey, you know what? I am using AI agents to fill in the paperwork. The paperwork itself is the problem. Not that I have to do it so much, that it is a thing that needed to be done. And I want to tell you more details, but it will, I can't. I want to talk about it, but I can't right now because it's something that's, something you're not supposed to talk about certain things, right? There's certain things that you can't talk about. Okay. How's it going there? Rival Sebastian, good to see ya. Happy Sunday, good to have you here. All right, you guys. We have, let's see if we can run a test now. Let's see if we run the test here. .tests. Hold on, we need to open up the cargo run. All right. Run the test. It's working. All right, it's working. No errors. There we go. Look at that, you guys, right there. Oh, it's so good. It's so good. Okay. Now, I just wonder if we can get rid of this. Can we remove this? Yeah, can we? Can we? Is that something that we can do? Because if we can do a .into, now that we've mutexed it, do we still need the app state? Let's find out. Let's find out. Here we go. All right, so, okay, so it still works, So I want to do that. Let's say this. We're not going to bother about the app state anymore. Nope. Save, okay. Expected app state, right. So we need to go back to this. Say it is a rag, right? Rag state. Unsatisfied trait. Oh, it's back to where it was again, right? Arc. Oh, hey, wait a second. No, there we go. Hey, I figured as much. All right, now I'm happy. Because I think we can delete this. Paperwork is always frustrating. Sure is, Rox, it sure is. What are we building, Rival Sebastian? We're building a Retrieval Augmented Generation server, a RAG engine, which allows a user to ask a question, like a user prompt, in plain natural language. And we can provide the exact results that they're looking for, or very close to it, right? Basically a Google search for all of your corporate enterprise. And we're gonna do it the good way. We're not gonna do it naive, we're gonna do it the good way. We're gonna use standard keyword matching, full text search, and vector search combination for ranking. That's what we're gonna do right there. We'll use local models to add the answer in natural response. We will also be using a vector store, which is Turbovec, for extremely fast retrieval. Skinwalker used Lisp, hey! Oh, wait, I know Lisp! Oh, Steven's a CII spy. Derek, I don't know about that, but we are making progress here. We are definitely making progress. Let's do this. Okay. And then can we bring this back? Look at that right there. Right there, you guys. Rebuild. Run. All right. Test. Yep. While true. Do. Test. Sleep. 1. Done. Look at that. So good. So good, you guys. All right. Let me clean up. Let's clean everything up now. We did it. There we go. Okay. We got our SQLite. We also need to do our schema next. Schema. This will be for tomorrow. We'll do our schema tomorrow for our database. And if we have got time, we'll do our embedding. We'll do a Turbovec and the LLM as well. There we go. LLM, Turbovec, schema. We did the SQL. We got our DB. What we should do though is, so SQL in state is what we did today. State, we did this. Let me grab the check mark because we need our reward because we did it, you guys. We did this part. We did good. Let's see here. Okay. Now we need to do our SQL handler, probably a mod, right? So we'll do a new module. So that way we can more easily deal with these things, right? Then we'll have our baked-in schema all in one. So we can do both of these things right here. So that'll be the plan for tomorrow. We need to do this tomorrow. To do tomorrow, and then maybe we'll do this other stuff later. Like maybe, so this will be Monday, right? We'll do this on Monday. Tomorrow, Monday. And then on Tuesday, we'll do this one. To do Tuesday. We'll start here. Maybe. If we make progress, we can do it. Okay, so let's clear this. Saved. Good to go. Looking good. Okay. Like to see it. Like to see it. Let's move this down to here. You know what? Maybe we should move to the bottom. Can we do that? Yeah, we'll move it to the bottom. So that's a little bit more clean. Keep our structs at the top. Looks good to me. All right. Cool. All right, you guys. We're going to wrap up now. So good to have you here. Thank you for joining. Let me commit this code really quick. Git add. Here we go. We're heading on now. A simpler way to do what you just did, Steven, is watch. Oh, to watch to see if it change. All right, let's do that, Bunzupi. We'll do that real quick. Let's see. So you say watch. Yes, the watch command in one for 1 second, right? Watch 1 second dash in one, and then you say ./ test. Yeah, test. There you go. Oh wait, that didn't work. ./ test in one. Yeah, that should have done the trick right there. Why didn't that work? Hey, hold on now. Watch. Oh, I don't have the watch command installed. Hey, that's why. All right. So we'll have to do the while for now. Bye, Rocks. All right, bye, Bunzupi. What? Hey, what? You just joined right when we're wrapping up. We're gonna say we'll be back tomorrow. We'll be back tomorrow, you guys. The plan for tomorrow is to continue on with creating a module in SQLite, and we'll write our schema. Sure. Derek, good to see ya. Every in seconds, clear the terminal screen buffer, preventing the polluting your log terminal. Yeah, that would have been good. That would have been. Oh, every command, yes, it'll run the command. Yes, exactly. Watch would be the way to do it. All right, you guys. Bye, guys. Sergio, good to see ya. Bunzupi, Derek, what? Rocks, Snot, good to see you guys. Rival Sebastian, Skinwalker, good to see you. All right, you guys. And Talking Bats as well. See you guys tomorrow. Have a good rest of your weekend. We'll be back on Monday. Game over. What? Game over. Yep. All right, guys. See you tomorrow. Bye, everybody. Have a good rest of your day.